Welcome to True Projects. In this video, we are going to explain about the project that is facial emotion recognition through custom lightweight CNN model performance evaluation in public datasets. Before getting into the execution, first let us understand what is the project about. So, facial expression recognition, that is FER, it is basically about figuring out what emotion someone is feeling just by looking at their face. Think about our emotions play a huge role in how we communicate. A smile, a frown, or a raised eyebrow can say a lot without us even speaking. Now, where earlier methods for FER use things like psychological sensors, which measure changes in the body like heart rate or brain activity to detect emotions. But there is a problem with these methods are intrusive because these methods are intrusive. Imagine having to wear sensors or being hooked up to machines just to recognize emotions. It is just not practical, especially if we want something that works in real world situations. So that's where deep learning and computer vision comes in. So here where computer learning and deep learning, computer vision and deep learning steps in. Instead of relying on physical sensors, modern FER systems that analyze facial emotions, that is facial images. So here where CNN comes into the picture, that is called convolutional neural network. It is really good at identifying patterns in the images, which makes it perfect for this job. But here the problem is many powerful CNN models like VGG16, ResNet 50, and Inception V4 are super accurate but come at a cost. They require a lot of computational power, meaning they aren't ideal for mobile devices or any systems with limited resources. And here, one of the biggest challenges that we have is with the facial expression recognition is finding the right balance between accuracy and efficiency. So we want a model that can correctly identify emotions but also runs smoothly on different types of devices. The problem with many existing deep learning models is that they need a lot of processing power. That is fine if that is fine if you are running them on high end computers or a powerful server. But what about the mobile phones or devices with the limited resources? They just can't handle these heavy models well, which makes it real time applications difficult. Now, where lightweight MobileNet V2 and ShuffleNet V2 that are designed to work on lower power devices. They are optimized to use fewer resources while still performing well. But when it comes to FER, they still have some limitations, meaning they might not be accurate or reliable as we need them to be. That's why researchers are focused on creating a compact yet powerful model that not only works efficiently but also consumes less power. This is especially important for real world applications like healthcare, psychological analysis, and also human computer interaction, where quick and accurate emotion detection is essential. Imagine a mental health app that monitors emotions through facial expressions. If model is slow or inaccurate, it loses its usefulness. So the goal is to develop something that is fast, lightweight, and still performs at high level. So basically, this project is about designing a lightweight yet accurate model for facial expression recognition. And the goal is to identify emotions from facial expressions using deep learning approach, but without heavy computational demands that many existing models have. And to achieve this, this project develops customized lightweight CNN based model that is CLCM with the help of MobileNet V2 as the backbone. So now why MobileNet V2? Because it is specifically designed for lower power applications, unlike heavier models like ResNet or VGG. MobileNet V2 uses depth-wise separable convolutions, which helps to reduce the number of parameters and makes the model efficient without compromising too much on the accuracy. So it's a good choice for applications where computational power is limited, like mobile devices or embedded systems. And to improve the model's ability to recognize emotions, here we are using transfer learning models. This means that instead of training the model entirely from the scratch, it leverages pre-trained knowledge from larger data sets, allowing it to extract better features and also recognize emotions more effectively. And now, how do we know if it actually works? So the model is tested on multiple benchmark data sets that are FER 2013, RAF, DB, EffectNet, and CK plus dataset. These are the well-known datasets in the field of facial emotion recognition, and the goal is to classify expressions into seven basic emotions. So here we will be categorizing the facial emotions into seven different emotions that are happiness, sadness, disgust, fear, angry, surprise, etc. And to make sure that all these models are performing well, it is compared with the Lightweight MobileNet V2 and ShuffleNet V2. So existing lightweight MobileNet V2 and ShuffleNet V2 are being compared to the proposed model, and they are evaluated. I mean, all the models are evaluated using accuracy, precision, recall, and FN score, which are used. And these metrics help in understanding not just how many correct predictions that model makes, but also how well it distinguishes between different emotions. So this is all about the proposed system. Now, to further improve the performance, here in this project, we are incorporating the exception model. So to further improve the performance, we are incorporating exception model to enhance the classification performance. While MobileNet V2 also uses depth-wise separable convolutions to improve the efficiency, this exception takes it to a further step by fully replacing standard convolutions with depth-wise separable convolutions. This allows for more effective feature extraction, leading to improved classification accuracy while maintaining computational efficiency. And additionally, a detection module is introduced using YOLO family models, enabling high accuracy of face detections. This addition ensures that system can not only classify emotions but also detect and track faces efficiently, which makes it suitable for various applications. And we have developed front end of this project using Flash framework, which provides a seamless way for users to interact with the system. And the interface includes user authentication, ensuring secure access and the usability. This makes the system applicable in scenarios like healthcare monitoring, emotion based human computer interaction, and physical assessments, that is, psychological assessments, where secure and efficient emotion recognition is essential. So, this is all about the extension. Now, to further, to implementation of the project, we have followed the steps mentioned in the flow of work. So we have followed some set of steps for classification and the other set of steps for detection part. So let's see what are the steps followed for classification. So for classification, first we have loaded all the necessary libraries like TensorFlow, Keras, NumPy, and OpenCV. Then comes exploratory dataset part. So here all the datasets that are four datasets CK plus, Young, EffectNet, HQ, RAF, DB, and FER 2013 are used to train the models. Here we read and also analyze the sample images to understand the data distribution. Then comes image data augmentation. So here this enhances the data diversity using transformations like rescaling the image, which is normalizing the pixel values. Shear transformation is distorting the images slightly for the robustness. Zooming the image is adjusting image size randomly. Horizontal flip is flipping the images to make the model rotation invariant. Reshaping the image, it is resizing the image to a uniform shape for model compatibility. Then comes function for the calculating recall precision FN score. So here we define a function to evaluate model performance. Then we define early stopping to avoid underfitting, overfitting. So here we prevent overfitting or underfitting by stopping training at the right time. Calling the model. So here we load all the classification models, that is MobileNet V2, exception, etc. And also we define the CLCM model. Then comes building and training. So here we train the model using augmented data set and we select the best performing model. We save the best performing trained model for further emotion classification. So this is how we have done the classification. Now moving on to the detection. So similar to classification, here also we load required packages that are OpenCV, NumPy, PyTorch, and YOLO related libraries. Then comes exploratory data analysis. So here we will be loading all the four data sets and we will be reading and visualizing the sample images. Then comes image processing. So here we will convert images into a format that is suitable for YOLO processing. And here we define, so here we will be converting images to a standard image size. And then we will be defining the classes, that is we assign emotions and categories. We declare bounding boxes, that is identify face recognitions. And we convert numpy array. We convert image to numpy array, that is we optimize images for processing. Then comes loading pre-trained model. So here we use YOLO models, pre-trained weights for the face detection. And then comes image processing. So here we further refine the images where we will be linking images with the labels. And then we standardize the color format from BGR to RGB. And we highlight the detected areas. We adjust the image dimensions, and then comes the data augmentation where where we will be improving diversity with the randomization, rotation, and also transformations. Then we install required packages for the YOLO model to ensure all the dependencies are installed. And then we format images for YOLO based face detection, and then we define the YOLO based detection architecture. We train the improved face detection. We train the model to improve the face detection accuracy. And then we save the best performing YOLO model for the further detection. So this is how we have implemented the detection. Now moving on to the front end. So here we have developed front end using Flask framework with SQLite for user authentication. And then comes user uploading the images. So users they provide an images for emotion analysis. So here users they can upload images for classification, and here we will be doing prediction for all the four data sets. Accordingly, detection part also. So they can do detection using all the data sets. And that given inputs, I mean that given images will be pre-processed at the backend. It will be fed to the train model. Finally, train model will be predicting the facial emotion and display through the front end of the application. So this is how we have implemented. Now moving on to the algorithms used. These are the algorithms used in this project. This is the proposed model and this is the extension model. And here complete detection module itself is the extension part. So here we have used multiple YOLO based family YOLO models, that is YOLO v5s, YOLO v5x6, YOLO v8 and YOLO v9. So these are the models used for detection of the facial emotion, which will highlight the regions and detect the facial emotion. And to implement, we need basic requirements, which are hardware and software. Coming to hardware, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. And software requirements are applications of Anaconda, primary language of Python, front-end framework of Flask, backend framework of Jupyter Notebook, database SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So this is the overview. Now let's execute. To execute, we are supposed to open the code folder that contains source code files. So let's open the code folder of the project. So here we have two subfolders. I mean, in the code folder, we have two more subfolders. Let's understand each folder. How will they be used in this project? First, let's open the application folder. So here in this sample folder, we have the images that we will be using in the front end for testing purpose, and this is the static folder. In this folder we have CSS, JavaScript and Bootstrap files, which are important for the visual appeal. And here this is the templates folder. In this folder we have HTML files that will be used in this project. So for example, we will be having index.html, about.html, etc., which will be rendered at the time of web application. And here we have app.py file. So this is the .py file, I mean Python file, in which we will be having the front-end code. While it contains information related to front-end logic, and it includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. This is the signup.db file. This file is the database file which is used to store the user information. And these are the model files in which we have algorithm information is stored, and that will be loaded into the project code during runtime of the application. So now let's get back and open the notebook folder. So open the notebook folder. And here, all these folders contains the data set and all these are the Jupyter Notebook files. So let's see first these folders. So these four folders are used for detection and images which are in these folders are used for classification. First, let's see the images which are used for classification. Open dataset one. So here we have dataset which is split into two subfolders. One is train and the other one is test. So let's open the images which are in train folder. As we are predicting seven classes, here we have seven folders. So let's open the first folder. So here you can observe images, right? So this image, I mean, for emotion of these emotions seems to be surprising emotion. It is surprising emotion. Let's get back. An emotion in the folder 2 contains the fear. So these are the images of emotion fear. And in this folder, we have images of disgusting. And in this folder, we have images of happy, and images which are here contain sadness, and which are in this folder contain angry, and images which are in this folder contains neutral. So let's get back. So images which are in train folder are used to train the model, and images which are in the test folder are used to evaluate the model. So in test also we will be having the images, but these are used for evaluating how the model performs. Accordingly, we have in dataset 2 also, we have seven different classes. So these are of angry emotion. So here are the images of angry emotion. And here we have of disgusting emotion. And here we have of fear. Accordingly, we have for other emotions also. In the same way, we have in dataset 3 So here are the images of anger. Accordingly, all other emotions. And in dataset 4 also we have total 7 emotions. So here all the images represent anger, and here all the emotions represent disgusting, and here all the emotions represent contempt. So in this way we have in other folders too. Let's get back. So images which are in these folders are used for classification purpose only. So we will be training all the models for classifications. So here we have images for detection purpose. So let's open dataset 1. So we have images in the train folder. Let's open that. And here we have two more subfolders. Let's open images first. So here all emotion images are clubbed together, whether it is anger, happiness, disgust, sad, and all they are clubbed in this folder. And these are the models used to, these are the images used to train the YOLO model for detecting the emotions. So here in the label folder, we have the annotation files. So these files contains the annotation files or labels for objects in the corresponding images. So here each label file corresponds to an image file in the image folder. For example, this label file, it corresponds to this image file. Accordingly, for the second image, we have corresponding label file. Accordingly, for all the 785 images we have in the image folder, here you can observe, right? Total we have 785. We have total 785 annotation files, and these annotation files they follow the YOLO format. Let's open a file for sample. So here this line represents a detected object, and this line specifies object class index. This is the object class index, and it is followed by bounding box coordinates. This is x limit, y limit, width, and the height. Closes. In same way, we will be having in all other files too. So images which are in train folder are used to train the model, and validation folder are used to evaluate the model. Let's get back. Accordingly, we have in dataset 2, dataset 3, and dataset 4. And here we have notebook files. So these are the notebook files, which are the Jupyter notebook files, which contains the combination of code, graphs, and outputs all in one place. And it allows users to write and execute code in individual cells, which makes it a popular choice for the data science. So here all these notebooks are for classification. So these four notebooks are for classification, and these four are for detection. So in this notebook file, we will be loading this dataset and training the model for classifying on that particular dataset. Accordingly, dataset 2, dataset 3, and dataset 4. In similar way for detection also. And here these are the model files. So these four are the model files. So let's get back. And now let's execute. To execute this project, copy the path of the code folder from the address bar of the file explorer. I'm copying it. Now open Anaconda prompt. So here it is open. Give the command cd, give the space, and paste the copied path. And now click on enter. Here you can observe, right, current directory is changed to the code folders path. Now compile app.py file. So give the command python space app.py and now click on enter. This command will execute Python script and perform runtime check for any syntax errors or logical issues. And after running this app.py file, Flask Framework will host the application at the default address, which is the local host and the port, unless configured differently. Just wait for a while. App.py file is being compiled at the backend. So here Flask Framework has hosted the application at this address. So this is the local host, and 127.0.01 is the local host and 5000 is the port. Now copy this local link provided by the Flask Framework and paste it in any web browser. I'm copying it. I prefer Google Chrome, so I will paste it in that. Paste the link here, click on enter. So this is the web page of the project, which is displayed in the browser. And this is developed using Flask Framework. So we need to register first. So click on register and enter all the registration details if you are registering newly. I have already registered, so I will directly sign in. So click on sign in, give your username and the password. Click on sign in. So here we have signed in successfully and we are redirected to classification page of the project. In this project, we're doing classification and also detection as well. Detection is the extension part. So first, let's do classification. And here we are using 4 data sets in this project to detect the facial emotions. So first, let's do classification using dataset 1. So click on that. So here you can see choose file button, right? We need to click on that for uploading the images. So click on choose file. So first we are supposed to open the sample folder in which we have test cases. Now we are doing classification. So open the classification folder. As we are doing classification for dataset 1, so open dataset 1. So images are in these different folders. So let's open images from the folder 1. So let's upload this image. Click on open. Here it has been loaded. Now click on upload. So this given image, it will be pre-processed at the backend. It will be fed to the train model and then train model will be giving us the prediction. So this is the uploaded image and here we got the prediction that person's emotion is surprise emotion. It is the surprise emotion. So now let's check with the other images. So click on choose file. Similarly, let's give this emotion, I mean this image and see what will be predicted. So this image seems to be surprise. So here also the application has correctly predicted that person emotion is surprise emotion. Now let's check with the other cases. Click on choose file, open class 2 folder. So now let's upload this image. So the given images are looking like a fear emotion. So click on upload. Now let's see application will correctly predict it or not. So this is the image that we have uploaded and here we got the prediction that person emotion is fear. So it is correctly predicting. Now let's check with one more image from the same folder. So let's check with this one. Click on upload. And here we got the prediction that person emotion is fear. Now let's check with one more data set. Sorry, one more folder. Get back, open 3 folder. So these images look like a disgusting emotion images. So let's upload this one. And let's see application will predict, I mean what it will predict. So this is the image that we have uploaded and here we got the prediction that it is disgust emotion. So here it is predicting that it is disgust emotion. Click on choose file to upload images from the other folder. So let's try with this case. So images seems to be happy. Let's try with this image. And here we got the prediction. So this is the one that we have uploaded and here we got the correct prediction that person's emotion is happy. That means person is happy. Let's check with some more. Open fifth folder. So it is like sad emotion. So let's try uploading this one. And here we got the prediction. So here it has been predicted as sad. So it's a sad emotion has been predicted. Let's check with two more folders of the same data set. So open classics folder. So these images seems to be anger, right? So let's see what will be predicted. So this is the image that we have uploaded and here we got the prediction that person's emotion is angry. So your person emotion is angry. Click on dataset 1. Get back. Let's upload last image for this data set. So these images seems to be neutral emotion. So let's see what will be predicted. So let's upload this one. And here we got the prediction. So this one is the uploaded one and here we got the prediction as neutral. Now let's check with the dataset 2. So click on dataset 2. Click on choose file. Open the classification, open the dataset 2 folder. So let's upload images from this folder and see whether application will correctly predict it or not. So let's upload this image. So here we got the prediction. So this one is the uploaded one and here we got the correct prediction that it is angry emotion. Let's check with some more. Open discuss folder. So let's try with this image. And here we got the prediction. So this one is the uploaded one. And here we got the correct prediction that person seems to be disgust. So here we got the prediction that person emotion is disgust emotion. Let's try with some more. Now let's try with this folder. So these images seems to be fear, right? So let's try uploading this one. So this one is the uploaded one. And here we got the prediction as fear. Now let's check with dataset 2 itself. Click on choose file. Now let's check with the happy folder. So select the image. And here we got the prediction. So this is the uploaded one. And here we got the prediction as it is happy. Click on choose file. Let's upload images from neutral folder. So these are the neutral images. So let's upload this one. And here we got the prediction. So this is the uploaded one. And here we got the prediction that person emotion is neutral emotion. So let's try with some more. Click on choose file. So now let's upload images from sad folder. So these images seems to be sad, right? So let's upload this one. Here we got the prediction. This is the uploaded image. You can see this is the uploaded image. So here we got the prediction correctly that it is sad. It is sad emotion. So now let's upload image from the last folder. So these images seems to be surprising, right? I mean, emotion of surprise, right? So let's upload this one. And here we got the prediction. So it is surprise emotion. I mean, the person emotion, it is the surprise emotion. So we're done with dataset 1 and dataset 2. Now let's do prediction for the dataset 3. So click on that. Click on choose file. Open dataset 3. So let's open images from Anger folder. So these are the images. So now let's upload images from this folder. So let's upload this one. And here we got the prediction. So this is the uploaded one. And here we got the prediction as person emotion is angry. So here emotion seems to be angry. Let's check with the other files. So click on choose file. Now let's upload contempt emotion. So let's upload this one. And here we got the prediction. So this is the image that we have uploaded. And here it is correctly predicting that person emotion is contempt. And these images are the AI generated images. So click on choose file. Now let's upload images from this folder. So let's upload the first one itself. So here we can observe, right, this emotion seems to be a disgusting emotion. And here we got the correct prediction that person emotion is disgusting. So let's try with other image. Let's try with this one. So now let's try with this one. Shall I upload this one? So I have loaded it. Now click on upload. And here we got the prediction. So this is the one we have uploaded. And here we got the prediction that person emotion is fear. Let's check with the other files. I mean other images. So let's upload from this folder. Let's upload this one. And here we got the prediction. This is the uploaded one. And here we got the prediction that person seems to be happy. So it is predicted as emotion is happy emotion. Let's check with some more. Get back, upload it. So let's upload this one, or else let's upload this one. And here we got the prediction. So this one is the image we have uploaded, and here we got the prediction as neutral. So in this way, you can check with the other classes of data set 2, that is sad, and the remaining which are pending, that is sad and surprising. So now let's do prediction for the data set 4. So click on that. Click on choose file. Open data set 4 and open this folder. So these images seems to be angry. So let's upload this one. And here we got the prediction. This is the uploaded one. And here we got the prediction that person emotion is angry. Let's check with some more. Click on choose file. So let's open this folder and let's upload this one. And here we got the prediction. So that it is person emotion is surprising emotion. It is predicting correctly. Now let's check with this one, sadness. So let's upload this one. And here we got the prediction. So this one is the uploaded one. And here we got the prediction that it is sad. Let's check with some more. So now let's upload images from this folder. So let's upload this one and click on upload. And here we got the prediction. So this is the image we have uploaded. And here we got the prediction that it is disgusting emotion. In this way, you can check with the other cases of this data set. That is, you can check with the sadness, you can check with the fear, and also happy. So this is how you need to do the classification. So in classification, when we have uploaded the image, it is just telling what is that type of emotion. Now we will be doing detection. So it will identify the human and it will detect the emotion. That is the difference between classification and detection. It will draw a bounding box. It will tell it which particular emotion it is. So click on data one under detection. Click on choose file. Open sample folder, open detection. So open dataset one. So let's upload this one. Click on open and now upload and detect. So here you can observe, right? A bounding box is drawn around the face where it is capturing the anger facial features and it is drawing a bounding box around it. And it has given a class label that it is anger and given the probability score, which is nothing but the confidence level that how accurate the detection is in detecting this anger emotion. So in this way, you can try with the other images. Let's upload some more. So now let's upload this one, or else let's upload this one. So here you can observe, right? A disgusting class has been detected. So here it is drawing a bounding box around the face and it is predicting that it is detecting that this emotion is the disgusting emotion. Let's check with some more. So let's check with this one. Open it and now click on upload and detect. So here you can observe, right? A happy emotion has been detected and a bounding box is drawn. A green color bounding box is drawn. Let's check with some more. So now let's upload this one, which seems to be surprising. So here you can observe, right? Application is exactly correctly detecting that this emotion is the surprise emotion. Now let's try with some more. So let's upload this one. And here you can observe, right? Sad has been detected. Sad emotion has been detected. Now let's do detection for the dataset 2. So click on dataset 2. So click on choose file and open dataset 2. So this is the dataset 2. So let's upload this emotion, this image. And here we can observe, right? A sadness emotion has been detected. So here emotion sadness has been detected. Let's try with some more. So now let's try with this image. So here happy emotion has been detected. So now let's upload this one. So here you can observe, right? Anger emotion has been detected. Now let's upload this one. So here happy emotion has been detected. In this way, you can try with all the images that you have. Let's check with the dataset 3 under detection. Click on dataset 3 and click on choose file. So open dataset 3. So these are the images to be uploaded now. So let's try with this one. Click on upload and detect. So here you can observe, right? Angry emotion has been detected. So here angry emotion is detected and a green color bounding box is drawn. Let's try with some more. So let's upload this one. So here disgusting emotion has been detected. You can see, right? A green color bounding box is drawn around the person and it is predicting that it is disgusting emotion. Let's get back and try with some more. So now let's upload this image. Click on open and now click on upload and detect. So here you can see, right, happy, I mean person is happy. So application is detecting that person is happy and drawing a green color bounding box around it. So let's check with some more. So now let's check with this case. So here you can observe, right, person seems to be sad. So that is why application is detecting that it is sad. Let's check with some more. So now let's upload this one, or else let's upload this one. Click on open and now upload and detect. So here you can observe, right, happy has been detected. That means the person is happy. So that is why it is detecting person that is happy and drawing a green color bounding box. Let's try with some more. So let's upload this one and click on upload and detect. Here you can observe, right, a surprise emotion has been detected and a green color bounding box is drawn around the person. So in this way, you can try with all the images and test all the cases. And similarly, you can also do for dataset 4. So this is how you need to do the execution. So for classification, when you have uploaded the image, it was just classifying what was that emotion. And coming to the detection, it was drawing a bounding box around the emotion of the person and it is giving the detection. It is predicting what is that emotion it is. Now let's check with the graphs. Click on graph and click on dataset 1. So here the first graph we have is the classification. I mean, for all the models that are trained for the classification purpose. So this is the accuracy comparison graph. Here on x-axis we have accuracy score and on y-axis we have all the algorithms that are trained. And exception model, that is the extension model, has gained the highest accuracy. And this is the precision score, this is recall score, this is FN score. And here we have graphs of detection. So this is the precision recall curve graph, this is the FN confidence curve graph, confusion matrix, and this is the precision recall. I mean, this is the precision graph. And here we have recall and here we have mean average precision. So these are the YOLO models which are used to train the detection model. So YOLO models are used for detection purpose and all the models the above we have. So these are the models used for classification purpose. Let's check with the graphs of dataset 2. So similar to dataset 1, here also we have graphs first for the classification. So this is accuracy, precision, recall, FN score, and here we have for detection also. So accuracy, precision, recall, and FN score are used to evaluate the classification models. So coming to detection, we will be using mean average precision, precision, and recall for evaluating. We are done with dataset 2 graphs. Click on dataset 3. So here we have the graphs. The first graph is the accuracy graph. I mean, first graph we have for the classification, precision, recall, FN score, and here we have for detection, FN score, confusion matrix, precision, recall, and mean average precision. Let's check with the last one. Click on dataset 4. So these are the graphs of dataset 4. So now click on logout. In this way, just by uploading image to the application will be predicting whether the emotion is angry, surprising, or it is fear, like that. If you want classification, we can go with the classification. If you want detection, you can go with that. And if you want to go with both of them, you can try with both of them. So this is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.